Science. We got a great day today. We're going to be talking about dark matter. No, not the type that spins around in your toilet. We're going to talk a little bit about the dark matter that the people in Harvard, in Cambridge, Cambridge. These people say that swirls out there, around the galaxies. Find out what that is all about. And before I can get there, let me say the following. Last week I talked a little bit about science, physics, what physics is about, and some of the things that we require people who come here and question, some of the things we propose here, theories and so on. And, let me start with this. I think it was in the 70s, like 50 years ago, there was a movie, 1,000 Clowns by Jason Robards. And I thought that was a good title for what I'm going to be presenting here at the beginning. I seem to have a bunch of clowns come over here lately. And they want to challenge, the rope model and the version of science and the physics that we have here. And no problem. We have no problem with people challenging that. But, like I said last week, you need to know what this channel is about and what you got to do to counteract what we say here. And these people don't seem to understand that. I've tried a couple times now already. They don't seem to get the message. They keep insisting that they can get away with democracy. Everybody votes for a given theory or whatever. Or definition or whatever. Authority, this is what they told me in school, and so I just memorized it, and so I just regurgitate it here. Or maybe they go to a dictionary and just pull the definition that they found there. They don't understand it. It's irrational. They don't care. They just bring it in. Or what's the other one? Tradition. We've been doing this for 400 years, since the days of the 17th century revolution, and so we're not going to change what we've been doing. And, the issue here is that from the mathematical establishment, no one can tell you, something as simple why this pencil, I get smaller and smaller, the pencil, why this pencil falls downwards. They cannot tell you that. Not one person, 2,000 years, 3,000 years, no one can tell you why that pencil falls to the ground, not to the ceiling. Simple things like this. And they are very, very, extremely simple. And they can't answer those questions. And part of it has to do, with definitions, the fact that they never define words. We don't have rational definitions in all of mathematical physics, so-called science, we don't have them. Nobody ever dedicated time to that because they think that's philosophy. And so they leave the philosophers, they leave it to them, or to the English majors or ontologists or metaphysicists or whatever they call them. And they say, hey, you define the words for us. So we have people outside of the discipline of physics defining the words for physics. And of course they don't care, and the other guys just use it, and so that's where we are today. We don't have definitions. And so here we introduce a little bit of authority. You want authority? Here you have authority, okay? You have good old Juanito Baez, okay? And he created the crackpot index. Point number 14, 10 points for each term you use without properly defining it, okay? You must define words, the critical words, the ones that make or break your theory. You have to define those words in science and in physics. Okay, and if they're misdefined, we're going to have problems. We're going to have first problems in communication and also in you developing your theories. And I'm going to show that in a minute. But we need to define words in both science and physics. These people don't want to do that because they say, oh, that's semantics, that's rhetoric, that's that's word salad. For them, it's just noise. And no, you need to define these terms, the ones that are going to make or break your theory. And so here's the first word that we want to define so that you get an idea what this site is about, okay? And that's the word science and the word physics. We need to know what science and what physics is. Now, if you don't like these definitions, you got a better definition, hey, no problem. We challenge you to bring them over. But please don't bring the nonsense you'll find at the Wikipedia or in the dictionary, because those are trash. We have no use for those definitions. They're not valid definitions. They're not rational definitions. Okay? So if you get some other definition, a personal definition that you want to bring in, that you thought about, you crunched it really good, and you want to bring it over, hey, please, we want you to bring it over, okay? So let's make sure we understand that much. Okay, so here it is. This is science, rational explanations, okay? Period. Rational explanation. That's what science is. If it's irrational, it's not part of science, okay? And that includes all of mathematical physics. None of that is rational. Physics, what is that? Well, it's a branch of science, and it's rational explanations of what? Of causes and mechanisms. That distinguished from philosophy, which is rational explanations of purposes and reasons. So now we have a definition of science, physics, and philosophy. Physics and philosophy being branches of science. And those are the only two branches. Then there's all these sub-branches underneath them that you see there in lighter color. Okay, so what is a physicist? It's an individual who rationally explains causes and mechanisms underlying phenomena. Okay? What is irrational? Well, here's some criteria. Okay, using concepts as objects, that's the main one. Mathematical physics is famous for using all concepts as physical objects. We'll go over that today. Explaining without defining key words or using them inconsistently, and explanation does not follow from the assumptions. Unimaginable mechanisms, there's a couple more, but those are the main ones, okay? What is an explanation? Well, it's a reply to why an event happened in physics, okay? And so, yeah, it's you have to tell someone the causes and mechanism behind a phenomenon. That's what an explanation is. So we got the definitions in place. We think they're rational, they're consistent, they're comprehensive. You don't agree with them, we don't care. We don't agree in science. Agree has to do with religion, with opinions. We're not asking for opinions, we're asking for objective definitions. You have a different definition, put it up there and we'll talk about it. Okay, so that's the first one. People should understand what we propose here as far as science and physics. Okay, period. What other words do we define? Well, if you're going to do physics, you cannot be able to explain a mechanism. You cannot give a physical interpretation. You cannot talk about the causes unless you define these words. These words are sine qua non. Okay, so if you never define these words, you're not a physicist. Okay, if you don't understand the meaning or the significance of these words, why they're important in physics, then you haven't gone through kindergarten physics. That's how simple it is. Okay, and here it is. These are the foundations of physics. That's what we call them. They have nothing to do with philosophy. They have nothing to do with ontology, epistemology, etymology, word salad, word wizardry, any of those. These are the foundations of physics. You need to have these words if you want to give a physical interpretation, which is 100% of what physics is about. Physics is not about math. Physics is not about predictions. Physics is not about, fields and energy and all those words they have. It's about physical interpretations. That's what it is, okay? And so there you have the words. First of all, we say, again, physics are rational explanations of causes and mechanisms. The golden principle of physics, if you're going to explain a mechanism, you absolutely need what? An object. You can't do physics without objects, okay? So physics requires an object. And so one of the first words, at least, or maybe the first word you have to define is the word object itself, okay? That which has shape. It's not that which we can touch. It's not that which we can see. It's not that which is made out of matter. Or volume or mass or any of those. No, it's that which has shape, okay? It's all objects in the universe have shape, okay? Not all objects can be seen or touched specifically. Space, the opposite of object. If object is a thing, space is nothing. Okay, it's the antonym, it's the opposite. So if one is that which has shape, the other one is that which doesn't have shape. Distance, we need to have the word distance if we're going to talk about physical interpretations. Any physical interpretation, either you specifically mention the word distance, or indirectly you bring it into the discussion. Okay, so there you have it. Distance, separation between two objects. What is location? The set of distances from your target object with respect to all the others in the system or in the universe, whatever you are going to be, whatever your dissertation is about. Exist, very important word in physics, because physics is the science of existence. Okay, so it's a specific science, the science of existence. The word exist does not belong to ontology, to philosophy, to epistemology, to metaphysics. It belongs exclusively to physics. Okay, only physics deals with the word exist. Anyone wanting to have a discussion about what exists in the universe, whether they know it or not, they cross the line into physics. So you're going to talk about the existence of God, the existence of this chair, the existence of your mother. You cross the line into physics. Okay, now you have to define that word exist. Exist, physical presence, which requires an object plus location, which we have just defined. And then motion, obviously two or more locations of an object. Finally, concept, a word that invokes or embodies two objects. There we have it. Okay, so those are the definitions we propose here. We don't care if you like them or not. We don't care if they destroy your religion. Especially what we want is for you to define those words differently if you have different definitions for them. And if you don't, well, then you have to bow down to this. You have to live with these, because these are not only comprehensive, one depends on the other, but they are also rational. You can use them consistently. And so here's the words that mathematicians need to define. Whoever wants to challenge those, these are the words you got to define. Okay, object space. You can say something, nothing. Okay, distance, location, exist, motion, and concept. Those words form the foundations of physics. What is physics? Physics is not math. Physics is not doing experiments, tests, or whatever, verification, falsification, prediction. None of that has anything to do with physics. Physics, rational explanation. We don't care if you studied all year, if you went into the lab and measured and all that kind of stuff. We don't care. When you come to the conference, we want you to explain. What did you learn? Don't tell me that you ran a test, an experiment, and that you measured. That has nothing, and that you have predictions. Who cares about that? What we want is an explanation. Explain the mechanism. We need to know how Mother Nature runs her shop. Father Universe, God, the devil, whoever you believe in. Okay? So we need to know how this universe works. That's what physics is about. Okay? And when I say how, I mean why. In other words, we're looking at physical interpretations, whys. Okay? We want the whys. Okay? That's what a rational individual wants. He doesn't want a description. Okay, so here are some of the rules. Okay, scientific rules for definitions that we propose here. The first one is not mine. It's from a fellow from Texas, a friend of mine. Don't whine, define. I like the other one that I use, and that's can't define, can't use. Okay, just that simple. Okay. This is not philosophy, ontology, metaphysics, rhetoric, linguistics, semantics, word salad, etymology, epistemology, and all knowledge, or any of those. Okay, these are the foundations of physics. If you cannot define philosophy, ontology, metaphysics, or any of the others, then you cannot use these words because they are vacuous words. Okay, you are simply using words that you don't understand. You can just replace those words with the letter X, Y, Z, and we're in the same situation. We don't know what X, Y, Z is, okay, what it means. So you are not allowed to use them in science or physics if you cannot define them. Can't use the arguments of democracy, authority, or tradition to defend yourself. Oh, that's the way we always done it. Oh, all the boys at the math club voted for this, and this is how, my teacher taught me, or this is what I found in the dictionary. Authority, no tradition, no democracy. Okay? So none of those you can use none of those to defend yourself. You want to defend yourself with rationale, with reasoning. Reason your definition. Okay? Don't tell me that that's what you found in the dictionary and that's what your teacher told you. Okay, so that's the first one, definitions. The second major point, at least that I made last week, and I just want to regurgitate that a little bit, is that whoever comes here has to tell us what the invisible, intangible mediators that Mother Nature uses to do her daily work. And Father Universe and God and all these other fellows, right? What do they use? Here you have a pencil, okay? And once again, I let it fall down, okay? Always falls to the ground. Don't believe in me, you can run your test at home, whatever, right? We know that things fall to the ground, and they fall towards the center of the earth, essentially. And the question is, why? Why don't they fall upwards to the sky? And so the issue is, whoever wants to talk about gravity or light or magnetism, how a magnet attracts another, what electricity is, what an atom looks like, how it does its quantum jump and all this kind of stuff, any of those things, you have to tell us what the mediator is. Don't tell me that entanglement, this particle affects that particle with nothing in between. That's called black magic. That's called witchcraft. That's voodoo science or voodoo physics. No, if this object affects that one, there's something connecting them, okay? So, you need a mediator. And that's where the problem is. These people have always worked without mediators. And what they did, they substituted the mediators with abstract mathematical concepts such as field, energy, time, mass, etc. Okay, so this is where the problem is. And so here we go one at a time here. Here's light, okay? And this is what these fellows came up with. You recognize some of them up there. And what you see is what is known as an electromagnetic wave. What you're staring at is what you see there in writing, and that is an electric field, a magnetic field. And what are those? They're made out of all those arrows, and the arrows are numbers, known as vectors. So you have numbers, known as vectors, magnitude, right? And they make up the fields, which are also a value at each point in space, more numbers. So what you're staring at is a bunch of numbers being pictorially depicted, with arrows. And at the bottom, this scary thing where you see all these arrows, these numbers, and they're moving towards the right. So this is what they've shown us for now 200 years. So this is nonsense. You can't use the wave because there is no such thing as wave. Wave is just a bunch of vectors, okay? That's all it is. And other people say, hey, it's particles. And here you have particles. And we have a problem with that also because, they're not particles. In other words, they're not the corpuscles that they used to have in the days of Newton or Huygens and all these other folks, right? No, what you're staring at are corpuscles, and quantum has gotten rid of that. They don't use corpuscles. Everybody simulates them, everybody depicts them as corpuscles, but they're not corpuscles because quantum doesn't believe in corpuscles. They call those corpuscles classical mechanics. Quantum has magical particles, okay? They're not talking about particles. The word particle stayed over when it shouldn't have. They're talking about concepts. They're talking about energy. They're talking about frequency or whatever. They're not talking, or charge, right? They're not talking about physical objects, okay? They're talking about concepts, and they start moving all these concepts around. That's why we need to define the word concept, separate it or distinguish it from what an object is, okay? Those two are not the same. They're not synonyms. And more ridiculous one that they came up with is this one. What's going on here? Why can't I see this? I guess. Oh, I see. Hold it. Give me a second. There we go. Okay, so this is the quantum packet, wave packet, and Roger Penrose puts it in his book. It's called the wave packet, and you see that curlicue there, and that's what they show you, and they say, light, it looks like that. Well, we don't know what that is. Well, what is that? Is a standing wave of what? Is it a rope, a string, a cable? What is it that's waving up and down? Okay, so, you can't come up with this nonsense because you got to tell us what we're staring at. You can't say that's a wave packet, whatever that means. Okay, so we need an object. Okay, so whoever wants to talk about light has to bring an object. Tell us what is the mediator of light. And you have some people out there, they say that it's the waving of nothing. Yeah, sure, tell me about it. Gravity, here's another one. We have a spoon, falls to the floor, and we've seen this constantly, right? We all know that things fall to the floor. Okay, so some people say, well, it's pushing, we have these pixies pushing from above. Okay, so this is their theory. Okay, so this is what they propose, that the pixies or particles or whatever push from above, and that's why the spoon falls to the floor. Okay, we have problems with that, but you're welcome to bring particles if you can explain the mechanism, and you're going to have a lot of trouble explaining the mechanism, because why don't the pixies or particles push from below? What about the particles coming from the other side of the universe, from below or from the sides of the earth or whatever? So you're going to have a hard time explaining, this we all understand. Particles pushing this down, we all understand that. And the only issue here is, how do you explain the mechanism when you have particles from every direction? Okay, so that's what you would have to explain. And others do it with with a wave here. Okay, so the particle falls because, there are gravity waves. And I don't know what the mechanism there is. You would have to explain it to me, but some people talk about gravity waves. And that's what I'm trying to simulate there. I don't know. I don't want to, debunk anybody here. I just want to show what they say. They say gravity waves, and I don't know how they explain that gravity waves compelled the spoon to fall downwards, okay? And then we have something even worse. We have these warp number lines. This is what relativity proposes. They say what's happening is that when the spoon falls, you have these number lines. Those are the white, lines that you see there. Those number lines, they bend. And so, that's not a physical object that you're staring at. What they did was replace number lines with a net, with a fish net, a canvas, and gives a misleading impression that you're looking at a physical object. You're not. What they have is a description, a mathematical description, and that cannot substitute for a physical interpretation. And then obviously we have our model here, and let's see if I can get it in there. Here it goes. And we have the spoon. Every atom of the spoon is physically bound to every atom on Earth. Every atom on Earth is bound to every atom of the spoon. And so as the spoon approaches the center of the Earth, the ropes fan out. And that's why there's an acceleration. So that's our model, okay? We don't ask you to like it. We don't want you to say you love it, that you're going to believe in it. We ask you to understand what we're saying. Just understand it. That's it. And then you can go to your own home and reach your own conclusions, okay? So again, science is not about belief, about opinion. We don't care about if you vote for it or against it. None of that has anything to do with science. That's got to do with religion, with what you believe in, okay? So we don't care about that, not in science. Okay, here's magnetism. Again, we need mediators, the invisible, intangible mediators. And what the mathematicians usually say is that, you have the electrons from each side, from the south and the north side, and they're spinning somehow, and no problem. Okay, so the electrons are spinning. Great. And how does that produce attraction from far away? Okay, so if the electrons are spinning in the north and in the south, how does that produce attraction? We need the mechanism. Okay, don't tell me that the electrons spin and that you measured and you've got the proof and evidence and you can predict. We don't care about any of that. We want the mechanism. How an electron from one side, one magnet attracts an electron from another magnet. What is the mechanism? Okay, don't tell me that they do. Tell me what the mechanism is. Okay, that's what you got to do. I mean, this is not for you to say, hey, we measured, and the great scientists at Harvard and Cambridge, all these people, they measured and they've got the exact, they have precise values, and here's the equation. No. We need the mechanism. Okay, give us a mechanism. That's it. Yeah, that's physics. Okay, the rest is mathematical nonsense. Okay, electricity, more or less the same thing. This is what they show you. They show you that electrons, what they call charges, they move around. Okay, and they are negative, so they go to the positive pole somehow. whatever that means. We don't know what positive and negative is, so you got to explain that in physical terms. You can't say negative goes to positive. Okay, that doesn't tell us anything in physics. Okay, but we have a problem there because, you know, those electrons, why are those electron beads moving from atom to atom? You got to explain the mechanism. What compels them to move? Okay, I mean, even if you remove an electron from one atom, why would another one fill its space? Okay, what's pushing it out of its own atom and, you know, filling the hole that the other one left? So you got to explain that. You got to explain the mechanism. Don't tell me it does that. We've verified and we've proven and we can predict. We don't care about any of that. You know, you got to explain the mechanism, and that's where mathematical physics fails completely. They've never been able to explain this. They just say it is so. Okay, and here's the vacuum chamber, just so you can see something here. They got rid of the atom. In other words, they got rid of the nucleus of the proton and the neutrons. What they have is just electrons going, you know, across the space. They say, oh, it's just a flow of electrons. Yeah, so it's not that they go from atom to atom like you see on the top. It's that the electrons are flowing without any atoms. So they have electricity without atoms. Yeah, just like I say. So that's the new version or the latest version. And so you got to explain the mechanism. You know, I don't care. Before you can explain that, you got to explain this other one, which is the quantum atom, okay? And here it is. The quantum atom is just a bowling ball and a golf ball. Okay, that's it. One is called the proton. The other one's called the electron. One is positive, the other one's negative, whatever that means. We don't know. But the question is, you know, why doesn't that electron bead just fly away? Or why doesn't it fall to the bowling ball if the bowling ball not only is bigger, you know, more massive, right? They have the same charge, allegedly. But why doesn't it fall to the positive bowling ball if positive attracts negative? You know, why doesn't it get stuck there? And why doesn't it fly away? I mean, that's what you got to explain. Without that, you don't have an atom to explain anything. Okay, so you got to start with the atom. And here's essentially what I'm referring to. You have the electron bead, blue, going around the center where you have the three quarks that make up the proton. Okay, and as you can see, you know, the electron just goes around in circles from orbital to orbital or energy level to energy level for whatever reason. And for some reason, that electron doesn't go all the way to the center, and at the same time, it doesn't fly away. Okay, it just sends its energy out, whatever that is. So we have a problem with what these people propose, because none of that is rational. You cannot rationalize what these people are saying. There's no reasoning to it. Okay, so this is the problem. Okay, so now you know what you got to do. You got to define the terms, and you got to tell us what invisible, intangible mediators Mother Nature and Father Universe and God the Devil use to do their daily work. And once again, let me show you proof, evidence, prediction, falsification, the whole works here, right? We're going to let go of the pencil, okay? And it falls to the ground, right? And there's nothing here and there's nothing here, nothing that I can touch or see. So whatever is pushing or pulling this to the ground, okay, is invisible and intangible. Invisible, intangible. Get that through your head. It's invisible and intangible. You cannot touch whatever's here. You cannot see it. Okay? And so what's the issue? The issue is that you cannot say, hey, I went to the lab and I ran an experiment. What? What did you use? Did you use your eyes and your hands? I mean, you know, it's invisible and intangible. So don't come back and say that you saw it, you touched the mediator or whatever. You will not see, you will not touch the mediators. You have to conceptualize it. You have to visualize it. Close your eyes and visualize it. What they call armchair physics. That's physics. You have to tell us how this universe works. For that, you have to visualize what Mother Nature could be using, because we will never be able to see or touch the mediators Mother Nature, Father Universe, God, the Devil use. Okay? We got that? Okay, and like I said, we had the circus in town. I had a couple clowns, several clowns really, but I got two of them because they wrote quite a bit, and I hate it when people write a bit and I don't answer, you know, what they what they wrote. Okay, so yeah, I'm going to address what these people wrote. And here it is. Okay, this is the first fellow, and he says the following. He said the interpretations of quantum mechanics don't matter. Okay, so he says physical interpretations don't matter, and he says the predictions do. Okay, so he thinks that science is about prediction, physics is about prediction. So the interpretation of quantum mechanics do matter. Well, do they or don't they? I mean, he said they do matter, but when one wants to propose a new theory, right, one has to show that the current theory is self-contradicting. Well, we don't know about self-contradicting. We want to show that all of mathematical physics, especially all of quantum mechanics, is irrational. Okay, it's irrational. What is irrational? When you use concepts to as physical objects, as mediators, or when you cannot imagine the mechanism that is being proposed. And the first one's there, particle at two places, at once. Obviously, that's an irrational thing that nobody can imagine. What do you mean the rabbit is at two places at once? Well, what does that mean, right? Or maybe it's the cat, Schrodinger's cat. He's dead and alive at the same time. He's over here and over there. Here he's dead. He's over there. He's alive. Yeah, it's all nonsense. You cannot imagine particle at two places at once. Magnets attract because electron spins. I just covered that. So what? The electron spin. How does the fact that electrons spin in one magnet attract another magnet that has its electron spinning far away? I mean, how do you do that? Explain the mechanism. And virtual particles popping into existence from the void. What does that mean? Is that magic? Is that like the angels of the old days, like spirits? What is this? Supernatural stuff? Many worlds. Every step you take, you go into a different universe. Light waves of vectors. What do you mean it's a wave of vectors or a wave of fields? What nonsense is that? Muon shortens distance between two hills, two mountains. They come together because a muon travels at great speeds, because it has a short lifespan. What the nonsense is that? So the distance shortens between two mountains because the muon travels from one mountain to the other. That's what they're saying. Atom orbiting the electron bead, again, why doesn't the electron bead fall to the center, to the nucleus? Or why doesn't it fly away? So you got to explain the mechanism. You can't just say, it orbits, or it's next to the proton, or whatever. Electricity flow with charges. Charge is not a physical object. It's a value, 1.6 times 10 to the minus 19 coulombs. So we don't use that as a physical object. So you can't say that numbers flow. Okay, so electricity is not the flow of numbers. Graviton particles pull. Yeah, how do you pull with discrete graviton particles? That's what you got to explain. Okay, and entanglement. This particle affects that one with nothing in between. Tunneling. You have a particle that goes through the wall and turns into stretches its neck as a wave on the other side. What nonsense is that? I mean, again, we have these ghosts going through walls, spirits. Spin, what is spin? Well, they say a spin is not like a top, but then they always illustrate it like a top, and they say an electron spins. What do they show? A spinning top. And then they tell you right in your face, they say, by the way, it's not like a top spinning. Oh, okay, then what is spin? And they explain a lot of stuff with spin, and they say, well, it's just a number, whatever that means. Okay, we don't care if it's a number. It's got nothing to do with physics. Physics, you got to explain the mechanism. We want to see the physical object and the mediators. Cat is both dead and alive? Yeah. Tachyon comes from the future. It's so fast, faster than light, so they say it comes from the future. And then we have particle, a field excitation. A field excitation, what do you mean a field? Field is a bunch of numbers, so we have excited numbers. Exciting numbers, we call it, right? Yeah, so all these are defeat quantum mechanics because they're all irrational. Not one of them passes the rationality test. Okay, and here you have fields. Okay, talking about fields. Here's a field. Okay, particles interact via quantum fields. What do you mean they interact with via quantum fields? How can field be a mediator if field is not a physical object? There you see a field on the lower right, and it's a bunch of numbers. Okay, and they're vibrating. So what do you mean numbers vibrate? Is that what a field is? Vibrating numbers, and now you're going to use it as a physical object and say that particles that they mediate between particles? Fields transfer the information. You transfer information? How do you transfer information? What do? You catch it, the data with your hands and just throw it? Is that how you transfer information? It's irrational language. You cannot say you transfer information or you transfer energy. Those are irrational statements. Say information of the charge. That's even worse. Charge is a number, so they have the information of a number. And thus tell particles how to interact. Yeah. So we have all this field stuff, right? The field is what causes, right? The attraction. How do you cause attraction with numbers? Field is just a bunch of numbers. There it is. A value at each point in space. What part don't you understand? Field, a value or values, many values at each point in space. That's what a field is. Field is a bunch of numbers. So how can you say that it causes anything physical? The field is what leashes the dog to the doghouse. The field is the mechanism. Yeah, see, these people think field is a physical object. Now, so it's the electric and magnetic fields that are waving. How can they wave? The fields are numbers. So this is what these people have been taught, that fields are physical objects. They think fields are physical objects. And of course, the day you remove the word field from science, from physics, they're dead, because the whole religion of quantum mechanics and general relativity fall apart completely. They need the word field because the word field embodies numbers, math, and they treat it like a physical object, like if it was a paddle. You can push charges forward with a field, like if you hit it with a paddle. No, field is a concept, mathematical concept. They never learned this, and they've never been to kindergarten physics. So yeah, it's important to define words, to find out what these words mean. Okay, you have to define what the words mean. Okay, and here's a couple fellows. One is Sean Carroll. I want you to listen to him because he's going to tell you that a particle is a vibration of a field. So here you have a professional mathematician, and that is quite popular out there. And he doesn't know the difference between an object and a concept. He thinks a field is a physical object. So listen to him. Okay, here goes.
Is light, for example, a particle or a wave? A wave is sort of a vibration in a field. So what's the answer to this? This is the answer. It's fields. It's not a mystery. They always tell you that question. They never tell you the answer. You need to stop thinking of the world in terms of particles. You need to start thinking of it in terms of fields. There are particles in the world. No, there aren't. That's the secret that we physicists have never told you, but here I am, I'm going to tell you right now. The world is made of fields. So the atoms in this table, the electrons, the quarks, the protons, these are all vibrations in fields. There's a quark field that is vibrating. You look at it, you see quarks. There's an electron field that is vibrating. There's a neutrino field that is vibrating. There's a gravitational field that is vibrating, and so on and so on. That's quantum field theory. It is the very heart, the central organizing concept of modern physics.
The organizing central concept of mathematics. Yeah, without the field, quantum mechanics and all of mathematical physics goes down the drain, dies a sudden death, because they need that word field to be a physical object. That's how they explain all their mechanisms. And here's another fellow, just in case. His name is Arvin Ash. He says more or less the same thing. So this is not just an isolated case. I just want to document that. Okay, here it is.
In these turbulent seas, a large wave can be created. These are the real particles. The fields are always there and exist everywhere. Now, although they exist everywhere and you can't see them, they are not nothing. They are teeming with virtual particles. These are particle-antiparticle pairs that get created and destroyed. They come in and out of existence constantly.
What we call magic, black magic. They come in and out of existence constantly. What does that mean? Don't tell me they do. Don't tell me you measured it. Give me the mechanism. I need to find out how a particle suddenly loses length, width, and height and becomes nothing. And how nothing acquires length, width, and height becomes something. That's what we need. Just simple mechanism that you have to explain. That's it. Kindergarten stuff. Okay? Okay, and this fellow continues. The clown came over, and he says, light travels in a straight line. It's just that subsequent photons do not travel in exactly the same direction. Because I told them the other day that, when the sun turns around, when it spins, every atom there produces light, right? It does its quantum jump, but the atom is also spinning, not only according to me, but according to them. And so if the atom is spinning, every time it shoots a photon, the next photon cannot travel right behind it. It has to travel to the side like a water sprinkler that you see there. So the sun is a water sprinkler for light. According to quantum mechanics, because, all these particles are traveling in every direction. They travel in curves. And so the question, how do you get straight line with curves, right? So if you take a snapshot of a spinning light that shoots photons in a radial direction, the photons would look like it's come out of a water sprinkler. But if you focus on one photon, it travels in a straight line. Yeah, with respect to what? I mean, he's saying that, just focus on one photon. And so here we have a problem because here's what they propose. Okay, let me get this one out of there. They say that light. This is from the AI, so you got to believe in it. This is the official version. Light consists of what? A series of tiny packets of energy called photons. So one goes right after another. And so how do you produce that with the sun when the sun is throwing one photon, the atom and the sun both move, right? And then the second photon goes to the side, and the other one to the side, and the other one to the side. What you have is a water sprinkler. Light would never travel in a straight line. Okay, so we have a problem with that. That has to be explained. And these people have never explained it. Okay, so they say that light travels in curves. Okay, here we have another issue, the light speed. He says, light obeys the equation C equals frequency times wavelength. Great, at least he understands that. This is a description, not something that can be explained. Well, how come we can explain it? I mean, here you have the rope model, and we can explain not only the speed of light, why light is so swift, because it's a torsion propagating along a rope. And a rope tells you why it's a constant. Because the more frequency you have, the more you torque a rope. You have more links, frequency, and each link is shorter. And vice versa. If you untorque it, well, then the links are longer and you have fewer links. See how simple it was? So we do have an explanation. We just need to replace the nonsense of quantum mechanics with a rational model. That's it. And so, this is one of the things. They just give you the official version. They never thought about it, and they say we can't explain it. We don't intend to. We never will, because they never can with particles and waves. So they just believe. They just say, yeah, the mathematicians told us that it's a wave. And what is a wave? Why can't it travel faster? Why can't we increase both the frequency and the wavelength? Well, because it's light, and light always travels at sea. Well, yeah, it always travels at sea. Why? I mean, with a rope, we can explain that. A rope, very simple. More links, each link is shorter for the same amount of rope. And you untorque the rope, and now the links are longer, you have fewer links. There it is. That's the reason for the speed of light being a constant. Very simple. I just need to replace the nonsense of particles and waves with a rational model using a physical object. See, these people don't use physical objects. They use vectors, which they call fields, which they call light. And no, you can't do that. That's not a physical mediate. That's mathematical gibberish. That's what it is. Here's the atom. Okay, he talks about that. He says the atom is mostly empty space. He got that from Ernst Rutherford. What Rutherford said is 100 years out of date. Oh, that's news to me. It, I assume, refers to the planetary model of the atom. Oh, yes, to what other thing could he be referring to? I mean, it looks like this guy is just learning his stuff. He comes here, showing that he knows everything, and he doesn't know this simple thing. This is something he should have had in sophomore or at least freshman year, right, in college. People who still say this conflate what happens when we measure the atom with what happens when we aren't measuring the atom. Oh, okay, so when we aren't measuring the atom, what do we know what's happening there? Electron wave function fills space, and that is what the electron is. So it's an electron wave function. That's what it is, a wave function, whatever that is. It's another number, another equation. That's all it is. That's what an electron is, just a number. Explanation. Particles of light, photons strike the metal surface. I guess he's talking about the photoelectric effect there on the lower right, transferring energy to the electrons, which now have enough energy to escape the metal surface. Yeah, before they can escape, you got to explain the atom. Why don't they escape before being hit by light? Okay, so yeah, the electron bead comes out. If you hit it with something, with a hammer, no problem, we understand that. But the question, why doesn't it, before you hit it with a hammer, why does it fall to the nucleus, which is positive, and why does it spontaneously fly away? That's what you got to explain from the atom is what you got to explain. Okay, before you give the explanation for the photoelectric effect, something Einstein didn't do. He won the Nobel Prize for this nonsense, but he never explained the mechanism. He just did a little gibberish math there, and he said, oh, yeah, they gave him a Nobel. You got to explain the mechanism, and he never did. He died without understanding physics at all. Okay, so here's your quantum atom. So again, there you have it. Tell me why the negative electron doesn't get stuck to the proton bowling ball, which is positive. That's what you got to explain. What barrier is there? What prevents it from falling down? Okay, don't tell me energy, because that's not a physical object. I need a physical barrier there. Okay, so you got to tell me what physical entity is between the electron, the white electron there, the golf ball, and the bowling ball. That's what you got to explain. Okay, very simple. Baby stuff, kindergarten stuff. Just put something in there. Tell us what physical object stands between them. Or, some of these people come up with notions like the canvas for relativity, and they say it's that there is a physical object there, but they never mention the physical object. What object is a field? Are you going to put a field in there? Is that what you're going to put? So again, you need physical objects. Physics is done with physical objects. You can't do it with mathematical concepts. Okay? And the only thing he said, more or less right, I guess, is that quantum theory is unable to understand gravity. Yeah, it will never be able to do so. I kind of altered a little bit his statements, but yeah, that's true. And he says, Gaede will never be able to convince people quantum theory and relativity are wrong. Well, first of all, we never talk about right or wrong, because those are opinions. Okay, so it's never wrong, it's never right, it's never correct, it's never incorrect, false, or true. Okay, that's the first issue. The second one is here we're not in the business of convincing, because convincing is religion. Means that I'm trying to change your mind. Okay, that I'm trying to persuade you to think in a different way. We don't do that here. We don't try to change people's minds. What we do is we explain a mechanism with physical objects, and we show you that it corresponds to our daily experience. That's it. You understand it, we're done. That's science. Now you can go home and believe or disbelieve, or reach your own conclusions, run experiments, make predictions, falsify, whatever. We don't care. But here we just explain so that you understand. So what do we do with these fellows, people who think like this fellow? Well, here it is. Let me show you what we do. Okay, listen carefully. Here it goes. We have bam bam, just banging their heads. Okay, so yeah, don't let bam bam hit you in the head. Do it right, and that means you're going to produce not only definitions, but you're going to also produce mediators. Okay, we need to see physical mediators. I need to see them, with my own eyes. Okay, here's another bozo. We had another clown also. He's been around for some time, and the issue with him also is, what is science? Because he's got this distorted notion of science, and he just defends it on the basis of authority, democracy, and tradition. And those are no-nos in physics, in science. No, you have to use rationale. You have to rationalize them for us, reason them, right? And here it is. He says, what is science? And he says, Gaede's claim. Science requires visualizable, and we're really talking about physics, right? Visualizable mechanical explanations, not mathematics. Absolutely. We do not use mathematics for explaining. We cannot explain with mathematics. Mathematics is only a descriptive language and only uses quantitative adverbs. Okay? Has no other language in all of mathematics, just quantitative adverbs. Evidence is subjective, absolutely. Theories need not predict, absolutely. We don't predict anything. New phenomena, and he misquoted me again, so I have to, correct him there. Falsifiability is belief. That's what I said. Not it's desirable or undesirable. It's belief. Okay, when you falsify something, that means that you believe that, or you prove to someone so that you change his mind. Okay, that's all falsifiability is. That's what it has nothing to do with science, and Karl Popper be damned. Okay, no, we don't use falsifiability in science. That's got to do with religion only. Okay, science requires, this is what he says, science requires testable predictions. Testable prediction, whatever that is, not visualization. Mathematics enables precision. And he gives example of GPS timing, LIGO, waveforms. All are confirmed. Confirmed by whom? What do you mean confirmed? Confirmed by what? Evidence is objective. No, evidence is always subjective. That's why a prosecutor presents his evidence and the defense attorney presents his evidence, because it's all subjective. And the jury decides, which one they're going to believe. Okay, but above all, he's really got to define science. He hasn't defined it. He just says it's testable prediction, but that doesn't tell me what science is. He's got to define the word science, and hopefully he doesn't look it up in the Wikipedia or in any dictionary, because you won't find a rational definition in there. After 3,000 years, there's no scientific definition of the word science. Not a rational one, not one that we can use consistently. Okay. But the question we've got here is whether, testable. Do we do any testing experiments in science? And, I worked at AMD, Advanced Micro Devices, for many years. And, as an engineer, you're upstairs. You go into the fab area where they do the processing. And yeah, you run the machines every now and then, but hopefully an operator who runs it every day is much better than me at running the machine, right? Because they do it every day. But, the job of an engineer is not to come down to the fab area and use his hands. You stay upstairs in your office and you do a lot of, thinking, because you got to solve problems. That's your job. You get paid for that, not to run a machine, right? Like an operator or a technician. So you design an experiment, and who goes out there? A technician. You can call him a gopher, right? Go for this, go for that, go for coffee, pizza, whatever. And so he goes out there and he does the experiment for you. Okay, that's why he's a technician, because he's trained to do certain things. Like run the machines and run a test and come back with the data. He gives you the data, you analyze it. That's your job now, right? As an engineer, you have to crunch the information, do your charts, mean, standard deviation, variance, that kind of thing. And then you come up with a result, change the spec according to what the results of that are, and you give your presentation to your engineering manager, because he wants to know why you changed the spec and why he's got to sign it. And that's the job of an engineer primarily. I mean, we have a lot of stuff over there to do, but that's one of the things that we do. Scientist is no different, because in that sense, an engineer is a scientist, okay? He's got to come up with, what's happening, a theory, right? And because of that theory, he's going to change the specs and so on. And a scientist is the same thing. He's got to stay upstairs. I mean, I don't think Stephen Hawking, I don't think he ran any experiment or looked through the telescopes to find out if there are black holes out there. He never did any observation or any hand and eye work. His job was to sit. That's why they're called theoretical physicists. They're armchair physicists, mathematicians. And what they do is equations. And they try to explain, what's out there. And they came up with a black hole. Okay, so he's not the guy who goes on the line. He doesn't use his hands. He doesn't use his eyes. Okay, that's not what a scientist does. That's what a gopher does. So all I can say is, here it is. Don't be a gopher. Okay, that's not a scientist. And people think that science is about running experiments, right? And doing some kind of, test tube stuff where you mix liquids and so on. No, that's got nothing to do with science. Okay, that's a gopher. That's a technician, maybe an operator, someone who uses his hands and his eyes. That person is not a scientist. The person who is a scientist only uses his brain. He has to think. He's paid to think, not to use his hands. Okay? He's not a baker. He's not a butcher. He's not a car mechanic. No. He's a guy who theorizes. Science is only theory, explanations, okay, with respect to physics, right? So don't be a gopher, okay? Don't go for this and go for that. All these gawking gophers that we have out there, they think that science is about running experiments. And so we want to correct them. And here's another version of that, okay? Science is not, a scientist is not a detective, okay? He's not a guy who goes out there and looks for clues and collects fingerprints and, and does DNA. He doesn't do any of that stuff. That's the gopher who does that, okay? The job of a scientist is to be a prosecutor. And he's not a prosecutor in front of a jury. He doesn't convince a jury. He doesn't persuade the mathematicians. Okay, that's not his job. His job is to persuade Mother Nature. Or better yet, to make sure his theory matches what Mother Nature does. Okay, meaning how she does it, meaning why she does it, what mechanism, what physical interpretations we're going to give to the phenomenon. And so the closer you get to Mother Nature, the more you get closer to reality. You explain what happened. So, the scientist is not a detective. He's a prosecutor. He's a guy who explains. He comes to the conference. He has to explain. He doesn't say, I'm going to do an experiment for you. Why are you doing an experiment? I want to convince you that I'm right. Yeah, tell me about it. So, no. So once again here, just in case, here it is. Science, rational explanations. That's what it's all about. Physics, rational explanations of causes and mechanism. So we do have a definition, okay? What is a physicist? He's an individual who rationally explains causes and mechanism, okay? So we have a definition. You may say, well, I don't like your definition, Bill. Well, I'm sorry. We don't care whether you like it or not, okay? You have a different definition, bring it on, okay? We'll be glad to analyze it. Find out if you can use it consistently, if you can use it rationally, okay? Scientifically. Our bozo clown also talked about time, which I talked about last time. Gaede's claim, time is just motion comparison requiring observers. An hourglass refutes time dilation. Yeah, pretty much. And so this is his rebuttal. He got it out of Wikipedia. One would think that he came up with this. No, he didn't. He doesn't have the brains for this. He just went out to the Wikipedia, copied, modified it a little bit, and put it out there. And he says, time is what clocks measure. Great. Operationally, right? Operational definitions. Operational defined as interval in spacetime. What is an interval? You look it up. An intervening period of time. So here we have time is operationally defined as an interval, and an interval is a time. So we have that synonym, we have a circular definition. When you look up time in the Wikipedia, it says past, present, future, essentially. And you look up past, present, future, and guess what? Time. So we don't know what time is yet from the mathematical establishment. So yeah, it says comparison of two motions. Okay, that's what time is. Now he says time dilation is measured. GPS and muons, he gives two examples. He gave a couple more examples, but he essentially GPS and muons. He says that proves time dilation to him. Okay, so he believes that time dilation exists because of GPS and muons and accuracy and falsifiability and all that nonsense. And, I have in my book, my special relativity book, the Einstein twins. And guess what? The young one, he goes out there, they're twins, they're born on the same day, same hour almost, or minute, right? One of them goes out, comes back, and finds out that his twin brother, is much older than him. And this is obviously nonsense, poppycock, put up there by Einstein. And let me tell you why. Because, we measure years by how many revolutions the Earth goes around the sun. So when he comes back, when the young one comes back, the alleged young one who is 50 years younger or 20 years younger, we just count how many times the Earth went around the sun, and then we'll know how many years have gone by, okay? Because you can't use the year of Mars, you can't use the year of the Klingons or some other planet. You got to use the year of the Earth, because that's the one we count years with when we talk about the age of something, of someone especially. So, when the other guy comes back, he better have the same amount of years as the guy who stayed behind, because that's how many times the Earth went around the sun. Now, did he biologically age or not age? Well, that's biology. It's got nothing to do with time. If he has progeria, he caught progeria on the way out or whatever, that's biology. It's got nothing to do with time. The kids who have progeria are 12 years old and they look like 80 years old. Is that because they went into a time warp? And that's what these people believe. They think they confuse biology with time. Anyways, he says, an hourglass is a terrible clock for detecting relativistic effects. Yeah, no kidding. I mean, what hourglass does, here I have one, is, right? There you go. All the grains are falling. And what's the problem with the hourglass? Well, the closer you put it towards the Earth, right, to the center of the Earth, the faster it goes, which is the opposite of what Einstein predicted. And same goes for the pendulum. Pendulum out there goes slower than down here. So I don't know. I don't know what to tell you. The grains fall faster closer to the center of the Earth. So that defeats the principle of relativity that says it should be the other way around. So yeah, we get rid of the principle of relativity because it's nonsense. Okay, we don't measure years with atomic clocks, which are inaccurate anyways, because according to the mathematicians, if you take the thing at great speeds and to the black hole and come back, it's not going to read accurately. It's going to have this time dilation. So again, these people defeat their own theory, because you can't use an atomic clock to do anything, because you know that as soon as you move it at any speed or farther away from the center of the Earth, it's going to read a different value. And so they're just as inaccurate or accurate as this guy. They're both just inaccurate. This one I like better because it's a mechanical clock and it's a gravitational clock. It's the best clock to deal with gravity and time at the same time. Okay, so always using one of these hourglass sand clocks. They're pretty accurate, at least for 15 minutes or so. Okay, so what we have to do, we have to define in physics. You have to define what physics is before you can debate or talk about physics. He says, I'm not answering his criticisms of the rope model. We can't even get to the rope model right now because this fellow doesn't know what physics is. He doesn't know what science is. And I'm asking him to define science, to define physics. And of course, he's not going to do that. He's going to assume that I bought into his version of physics and science because that's what they've been doing for 400 years, and because it comes with a lot of authority, tradition, and all the mathematicians voted at the math club, democracy, right? We don't care about all that. You have to defend your definition. Not a single mathematician on planet Earth can defend those definitions. That's why their proposals are all garbage. We throw them in the trash can. Okay, so here it is. Gaede's failure to understand basic physics. Well, you can only say that if you define what physics is. Okay, so define physics and we'll know whether I fail to understand basic physics or not. Okay, and there we define it, and you don't have to accept my definition. This is a scientific definition. It's a rational definition that can be used in science. And what is science? Rational explanations. What is physics? A branch of science, and it deals with rational explanations of causes and mechanisms. There you have it. What is irrational or rational? We like to define it in the irrational mode. Those are the criteria using concepts as objects. That's the principle one. What's an explanation? Reply to a why an event happened, to a why question. Okay? You need to explain, the physical interpretation, the mechanism of a phenomenon. That's what it is. That's what physics is about. We're trying to understand the universe. That's what physics was supposed to be about. Why are we doing physics? Are we doing it to do numbers there, equations? Measure a table and say, I measured the table, give me a Nobel. I measured more accurately than Joey. What is that? That's nonsense. No, you have to explain something. It doesn't take any brains to measure a table and do an equation. Once you know the language known as mathematics, you can, come up with equations, with calculus, with, algebra or whatever. You can use all that because it's a language. And so what? You're just describing. You haven't explained anything. You haven't told me how Mother Nature runs her universe or what exists out there, which is invisible, intangible, the mediators, Remember? I can't see or touch the mediators, right? So don't tell me you went to the lab and touched and saw the mediators. You will never see or touch the mediator of gravity. You have to visualize it. You have to imagine it. Okay? Armchair physics, it's called. Or they call it. It's called physics. Okay, and here is what the Wikipedia says, right? Wikipedia says physics, the study of matter. This is their definition of physics, right? Study, what do you mean study? You study and you don't know nothing, but because you studied, you're a physicist, you're a scientist, because you studied. You studied for the test, you got a 0, and you're a scientist because you studied. A baby opens, or a toddler opens a book of biology. He's studying biology, reading and barely reading, and he's a biologist, he's a physicist, he's a scientist because he's studying. No, hopefully study, you never use the word study to define any discipline. Whenever you see the word study, it's irrational, it's an irrational definition. The study of matter, its fundamental constituents, its motion. Well, what is motion? Well, they define it as change. Blah, 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 blah. Change, blah, 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 blah. And change is motion. So you can't use the word change to define motion because it's a synonym, so we're done there. So we don't have a definition of motion, so we don't know what they said there. And behavior through space. Through space, you go through space. What is this, an ocean? You go through it. Okay, you go through space. I mean, you can go through an ocean, you can go through air, but you can't go through nothing. How do you go through nothing? That's what I want. You cut through it? I mean, part the nothing to the sides as you walk, right? So yeah, to say that you go through space is irrational. Okay, you don't go through space. You go to the moon. You don't go through space to the moon. You go to the moon. You always travel towards objects, to objects. You never travel through space. Okay, impossible to do so. Try it one day. Try to travel through space. And time. And so what are these things? Space, a continuum, a gradual transition. That's all space is. They don't know what space is. And they also call it an expanse, whatever that is. Time, what is time? Past, present, future. Again, if you look up those words, those are synonyms of time. They're defined in terms of time, right? Entity, what is it? Entity, because it says the related entities of energy and force. Well, what is entity? Well, something that exists. Okay, and what does it exist? They don't know because they have a synonym called reality or actuality or being. They have synonyms. They don't have definitions of the word exist. That's why they never understood what physics is about, because physics is the science of existence. That's why they don't understand what physics is. Energy, no clue. To this day, you had good old Richard Feynman. He said, oh, by the way, none of us know what energy is. Great. So why do you use something that you don't understand? They use this word every day. They use the word field every day. They can't define either one. Field they define as a bunch of numbers, then they use it as a physical object, as a paddle. Bang things with it. And force, just an action. So, we don't have a definition of physics because none of those words are defined, and physics is not the study of anything. We don't study anything in physics. Okay? Physics is the gopher, okay? The guy who goes out there and studies. When he brings the data and does his experiments, whatever, he brings them to the scientist, to the genuine scientist, and he's got to put 2 fingers up there or 2 or whatever, and he's got to think, like this. Okay? That's the scientist goes like this. You'll recognize him because in his office he puts 2 fingers over his nose and thinks. Once he thunk, then he publishes or goes to a conference and explains. That's a scientist. Okay, here we had last week also this cartoon Felix. He waves the horseshoe, throws it, and breaks a window, right? Very simple stuff. So I ask you, how did the window break? How would you answer to a 5-year-old, a 10-year-old? Well, hopefully you say, well, I don't know, Felix swung, a horseshoe, apparently made of metal, right? You can think about that. And because all horseshoes are made of metal, usually, right? So, and the horseshoe, the metal went through the window. That's how you would explain to anybody, and everybody would understand. This is not how our clown answers. This is how he does it, okay? He does it the mathematical way. He calls this science. And how does he do it? He waves the mass and throws it with energy, and the force is what goes through the window. So he does it with all these concepts. That's how he does mathematics. Okay, he waves the mass, certain energy, and there you go. The force goes through the window. Okay, so this is how a mathematician talks, and it's an irrational way of talking. Okay, you need physical objects to explain a mechanism. We want to understand how the window broke in this case, right? But physics is about how windows break. And we don't need any math to explain how a window broke. And let me give you a for instance. There was this fellow, he was recently killed, Charlie Kirk. Kirk, I think his name. There's a fellow who shot him. And he's going to be on trial, in January, I think, February. He goes to court, January, February, March, whenever he's got to go to court. Judge is going to ask the prosecutor, how did Kirk die? What do you think he's going to answer? Well, I'll bet you 2 beers, okay? If I win, you owe me 2 beers. If you win, well, you only owe me 1, okay? But I'll bet you anything that the prosecutor's not going to say, well, Your Honor, there was this mass, and it was traveling at great speeds, close to the speed of light, and the tensile strength of the skin was not quite as strong as it should have been, not 50 megapascals or whatever, right? Is that how a prosecutor is going to talk to the judge, to the jury, or whatever? No, he's going to say, look, a bullet went through his neck. That's how he would explain the mechanism of how this gentleman died. Okay, he's not going to go in there and give you a mathematical garbage that doesn't have anything to do with, with how the person died. And so this person thinks that you need to have numbers, you need to have values. And he says the following. He says, here, let me put him up there. Says, the window breaking example shows why quantitative analysis matters. Okay? And so what do I say? I say the qualitative part. Window broke when a horseshoe went through the pane. Period. So yes, he said, Gaede did not explain. Yes, I did explain. I'm telling you how the window broke because a horseshoe went through the pane, right? And so I did explain why, the mechanism of how the window broke. That's what we were trying to explain. And he says, oh, but you can't do it without quantitative, without quantities, without magnitudes and numbers and so on. And the first word he puts is the word horseshoe. Now, I don't know what the word horseshoe means in math. It doesn't ring a bell to me. I never studied the word horseshoe in math, and I studied a lot of math, but never the word horseshoe. I never seen it there. And he talks about the mass of the horseshoe, the velocity of the horseshoe, and the energy of the horseshoe. So he can't do it without the horseshoe. That's the point. He wants to do it with mass, velocity, and energy without a horseshoe. And no, he needs the horseshoe because the horseshoe is what has mass. It's the horseshoe that's velocity-ing, it's traveling, and it's a horseshoe that has, or whatever, impulse did, has the energy. So in order to have mass, velocity, etc., you need a horseshoe. You can't do the thing without a horseshoe. The problem is these people do all their explanations without horseshoes. Okay? They do it with what? They say, hey, it's space-time, and it's the field, it's the waves, it's the energy, it's time, What do you mean? You can't use those as physical objects. Which is what they do. You need horseshoe, you need a physical object, you need a rock, you need a tree, you need a dog, you need a house, you need a thing, a table, whatever. And these people don't understand that. They're so brainwashed to use the language of mathematics that, when you talk about objects, they say, what are you talking about? We do it all with all these concepts. We do it with field, with wave, and energy, and so on. And this is the problem. They have not explained, again, how would you explain the death of this fellow to the judge? Would you say, the energy and the mass? It's not a mass. It's called a bullet. And, it's not the energy. It's, and we don't care about energy in this case. It's irrelevant. We just need to explain why the guy fell, with all that blood on him. That's what we need to explain, the mechanism, how the guy died. Okay? What else can I say? I mean, this is where we have a problem with all these mathematicians. And so, here we have these irrational individuals. They're known as autistic mathematicians. They're all autistic. They don't understand. They really have mental problems. They do their little thing, like in the Rain Man, 84 matches, I think it was matches or toothpicks, fell on the floor and the guy, 84. Yeah, sure. That's more or less an autistic person. If he can do that, he's autistic. Okay. And there you have it. One guy, a rational guy, says, that's a pen. The other guy sees a cylinder. He says, no, it's pi r squared height. Oh, that's a ball. No, it's 4/3 pi r cubed. Oh, and so on down the line. Pyramid. No, it's length, width, and height over 3. So this is how they talk. They don't know the words pyramid. They don't know the word ball. They don't use things. They use concepts, mathematical concepts, and they think they've explained. No, they can only describe with that. They don't realize that because they're moving these things and saying, well, this is how the door moved. The force, the energy, the field hit it. Now, you can't say that in physics. You can't say that the field moved to begin with, let alone hit the door and broke it down. Not with fields. You don't do that with fields. Fields are numbers. Okay, and this, I don't know how else to explain to these people because they're really so brainwashed with all the nonsense all the language that they've been taught by rote. They just memorized all this and they say, oh, we understand. What do you understand? You cannot explain how this universe works. To this day, they cannot explain. Okay, and we're going to see a little bit about that later on when we talk about dark matter. They have no idea. Okay, so here's why the window broke, okay? He says, you need to know some quantitative physics to determine why and how the window broke using a horseshoe instead of it bouncing off the window. These guys are not talking about what happened. If the horseshoe bounced, past tense, consummated event, then we can say the window didn't break, so there's nothing to explain. If, on the other hand, the window is broken, we need to explain the broken window. What caused it? The horseshoe that went through the window. We do not need to know the tensile strength of the window. We do not need to know what the mass of the horseshoe is. We do not know what energy it was, sent with, or how much mass the horseshoe had. We don't need any of that information. Not to explain why the window broke. We're trying to explain why the window broke. That's physics. The other stuff is math. We don't need that math. We don't need that garbage. Okay, we just need to explain how the window broke. We need to find out why this pencil, falls downwards. I don't need any math to explain this. To explain, not to describe, to explain. What caused it? What was it? Something that pushed it? Was it something that pulled it? That's an explanation. Okay, I don't need to know how fast. I don't need to know the energy. I don't need to know how much this weighs. I don't need to know any of the numbers of physics, of mathematics. Okay, I just need to know what the object is and what invisible mediators came in contact with the object, with a pencil in this case, right? That's what I need to know. Okay, so Here we have it's just this bigger version so you can see it there. Yeah, it was a horseshoe that went through the window. It wasn't a mass, it wasn't a force, it wasn't an energy, it wasn't time, it wasn't a charge, none of those. What it was is a horseshoe. You can see it there, okay? Took a picture just when it hit the window, so hopefully I can present that to the judge and say, Your Honor, I can tell you how the window broke. This horseshoe went through it. Period. We're done. Baby stuff, kindergarten stuff. That's how easy physics is. Physics is kindergarten stuff. Math, you got to go to college to understand that language. Like you got to go to college maybe to learn Chinese or Greek, right? It's Greek to me. But and math is the same thing. You have to study the equations and so on, learn the language, right? Because that's what math is, just a language. But that's got nothing to do with the causes out there. We need to understand how Mother Nature runs her unit. We need to understand why the Earth doesn't fly out of the solar system. I don't need to know how much mass the Earth has or the sun or any of that. I just need to know what physical cause there is that's preventing, right? What barrier, whatever, is preventing the Earth from flying out of the solar system. Why does it circle the sun? I don't need to know any math for that. Okay, one thing has nothing to do with the question we're asking. We're asking a question of physics. Okay, and these people don't understand that. Okay, and finally we have this black hole, which we're going to talk a little bit about today. And he says, what are black holes? And Gaede's claim, black hole is not a what? Exactly. Black hole is not a what. What is a what? What is that which has shape? That's a what. Okay? So whenever you say, what is a table? You're asking the right question. When you say, what is a dog? What is a tree? What is a rock? You're doing fine so far. But if you say, what is energy? What is field? What is time? Then you have a problem because none of those are whats. None of those have shape. So it's an irrational question to ask, what is time? What is love? What is information? Those are irrational questions in physics. You cannot ask that question there. So what is a black hole? It's a mathematical concept. Black hole is made of what? A concept called singularity encapsulated by a concept called the event horizon. We have two concepts, one encapsulating another concept. Two concepts do not an object make. You cannot say that a black hole is an object, so that's where the notion of black hole fails completely. And black hole is all mass and no substance. So how does the concept mass move distant stars around? That's what you got to explain. Don't tell me that you have a lot of mass. That doesn't tell me anything because I still don't know the mechanism, how that mass affects a star far away, how it compels it to orbit it, or how it flays its skin alive, pulling all the gases from its surface. How does it do it from afar? The mass does it? By what mechanism? And again, a black hole is all no substance. So that's what a black hole looks like nothing. Absolutely nothing. Nothing inside of nothing inside of nothing. And encapsulating nothing. Okay, so what's his rebuttal? He says, rebuttal, black holes have evidence. Oh, evidence. You mean that thing that you used to convince the jury? S2 star orbit observed. Yeah, you saw a star orbit. You haven't told me anything about a black hole because the star is orbiting. You haven't told me how the black hole forces the star to orbit. That's what you got to explain, the mechanism. Don't tell me that you observed. Yeah, it goes around something, yes. And we have a totally different mechanism for that than this nonsense that the mathematicians came up with. Compact objects exceeding neutron star mass with no surface. Yeah, a mass with no surface. Yeah, I think all masses are without surface. Kilograms don't have surfaces. And no alternative model explains all observation. Well, mine does, so I don't know why he says no alternative. You got to read up on mine, and you'll find out that we do have an alternative for the black hole. Black hole is nonsense because it has nothing to do with mass. That's where the black hole fails, okay? It's got nothing to do with mass. Okay, the event horizon is testable. Yeah, what do? You stand on the event horizon on this abstraction? Try standing on data, or on love, or intelligence. Have you ever stood on top of intelligence? Yeah. So yeah, for this fella, I recommend the same thing that I recommended for the other guy. And here it is, okay? You bang your heads. Okay? Bam Bam, do your job. Okay? Little Bam Bam, I love him. He does the work for me. Okay. Okay, get out of here. You did enough. Okay, so let's move on to the main course of the day, of the night. Here it's night over here in Germany. Okay, here we had, we're going to talk about dark matter, and we had couple papers. Really, there's more out there. I pulled a couple just at random, okay? And here's one of them, and it's the headline news. Okay, so this is the world's first image of two black holes orbiting one another. Okay, so this came out, and so they say, well, how do you know that two black holes are out there? You know, have you seen them? Have you touched them? Have you, you know, where did you come up with this notion that two black holes are orbiting one another? In fact, they gave the Nobel Prize to the group that took a picture of all these gravity waves coming from two black holes. And it says, after decades of searching, astronomers have imaged two supermassive black holes in orbit around each other at the heart of quasar, whatever there. So they know that it's two supermassive black holes that are orbiting each other. They were able to image them. You know, they took pictures of this. Okay, I'm interested. Let's see, we want to see the picture of this black hole, see what it is that they took a picture of. Astronomers have captured a radio image, okay? I guess the extraterrestrials have radios, that's good. Showing two black holes orbiting each other for the first time, confirming a prediction. Oh, the predictions, yeah, that has eluded scientists for decades. Okay, the newly released image reveals a pair of supermassive black holes locked in a cosmic dance. Okay, I hope it's the cha-cha-cha, okay? And researchers say this new snapshot offers the clearest evidence. Oh, I guess evidence is to convince the jury, right? To convince people who don't know nothing. Okay, that's great, the jury. Yet that binary black holes, essentially two gravitational titans bound together, truly exist. Exist? What do you mean by exist? Oh, remember, they never defined the word exist, so we don't know what they're talking about, because they never defined the word object, they never defined the word exist, so we don't know if a black hole is an object, we don't know if it exists. You know, until they define those words, we don't know what they're saying. Okay, right now, they said nothing. And so here are the images, if you missed them. Okay, this is one black hole on the left. That's the one that got them the Nobel Prize, and now I guess they're trying to get a second Nobel Prize by getting the two black holes on the right. They don't look very similar. How that comes up with two black holes, I don't know. But of course, they give you that picture and people say, well, is that really two black holes? I don't know. I don't understand the picture. I'm trying to understand what these people are saying. And so what they put instead, they put stuff like this. Okay, here you see it. Okay, they put stuff like that and you say, oh, that I understand. Yeah, they're two black holes. I can see how they're going around. But see, this is a picture. This is, in other words, a drawing or a computer-generated drawing or whatever. It's not, the real thing. It's not the real McCoy. So this is the problem. These people are getting away with murder because they're putting these pictures out there, and they also put the other picture, but nobody understands that picture. So how do I look at this? Is this supposed to be two black holes? In what way? How do you make sense of that picture and say that it's two black holes? So they put these, much easier to understand, right? They put the pictures that they want to convince, to evidence to persuade. That's the point. Because they predicted it. So they have to confirm the prediction, right? They always confirm. Okay, so here you have, using the Event Horizon Telescope, scientists obtain an image of the black hole at the center of the galaxy M87. And you look at that and you say, hold it, that doesn't look like a black hole. Looks like a white hole to me. I mean, it's very shiny. It looks like a star. And they're saying that's a black hole. And you say, well, what do you mean a black hole? I mean, you could have fooled me. I mean, are you trying to sell me the Empire State Building here or what? I mean, I look at that and say, that's a star. I don't see any black hole there. I see a white hole, if anything. There's a supermassive black hole at the center of our Milky Way, the center of our galaxy, the Milky Way. So, okay, so that's what they say it looks like. And this is not very similar to this other stuff that they sent us last time. Okay, that's the black hole that they sold us last time. They say that's a real picture. In fact, actually, they took many pictures, right, to come up with that one, they say. So it's a collage of pictures, And that's the one they came up with. They liked that, and they got a Nobel for putting that nonsense there. But the question is, what are we staring at? What is that? I mean, I thought a black hole swallowed all light, that I shouldn't see any light coming to my eyes because the black hole swallowed all of it. And you can see it's got a little center, dark center there, the donut one on the right. And you say, well, what part of that is the black hole? Is the whole thing the black hole? Well, what are we staring at, right? So let's do a quick anatomy of a black hole. Here it is. Looks something like that, you know. We have the photon ring, which they say that you are supposedly able to see it. Then there's a photon sphere, which is a little further in that you are not supposed to see, you cannot see. Okay, so it's somewhere in there. The event horizon is further in, so the event horizon is somehow encapsulated, or this shell called the photon sphere encapsulates it, I guess. And then the photon ring goes around that. And then at the center of it all is a singularity. Okay. And all that, most of that stuff that you see, the light, the bright part, that's all the accretion disk. And what is that? Well, that's matter that's falling inwards or rotating around the black hole, waiting for the carousel, to go inside the black hole. Okay, so that's what they say a picture is of. Okay, and there you see on the upper left, one of the rings goes, one of the spheres goes in one direction, the other one goes in the other direction. So they created all this mathematical gibberish to try to describe what a black hole is. And then they tell you, with a straight face, that they don't know exactly what a black hole is or how it works. Yeah, no kidding. I mean, it's all math. And even if we concede all this, okay, tell me how this garbage, this nonsense that you're staring at, how does that affect a star far away? How does it compel a star to orbit around it? How does it compel, the skin of the star to fall towards the black hole? That's what we need to. I need the mechanism. Don't tell me mass does it, because mass is a concept and it's just a description. So yeah, this flying saucer that NASA sells to people. Well, if you want to buy it, that's true. You can believe in anything you want, right? Okay. So what is a black hole? Let's find out through the definition. Maybe we can figure this out. Okay. Black hole is an astronomical object. Absolutely not. It's not an object at all. Okay. So dense that its gravity prevents anything from escaping, even light. No, that's not what a black hole is. Black hole is a star that collapsed gravitational. This is the notion. This is where they got it, right? A big star, bigger than the sun, much bigger than the sun, that collapses gravitationally upon itself. It crunches all the matter, right? Eventually out of existence. No atoms remain in there, right? And what remains is the mass. You have the 5-ton elephant. You get rid of the elephant, but the 5 tons remain there. Okay, so the 5 tons are still there. And that's more or less what it is. In other words, it's all mass and no body, no substance, no matter, no nothing. I don't know if you can call that an object. I guess you can't, because an object is that which has shape. And so we have to look at these words and find out what they mean, because otherwise, these people are talking nonsense, saying that it's an object. Let's find out if it's an object. Okay, and here it is. Astronomical object, a naturally occurring physical object. I like that. What is an object? It's a physical object. Oh, okay. Now I understand. Perfectly clear. An object is an object that exists. Oh, they don't know what exist means, and there you see it at the bottom, being, reality, actuality, those are just synonyms. So we don't know what exist means from the mathematical establishment. So to say that it exists, we don't know what that means within the observable universe. What's an object? A contiguous collection of matter within a defined boundary or surface that exists, again, in space and time. Okay, what is matter? Well, any substance. So matter is any substance that has mass and takes up space by having volume. In other words, an object. And then you have substance, anything that has mass and takes up space. So it's a synonym of matter. So matter is substance, substance is matter. Great. Anything. What is anything? Anything, whatever. Something, no matter what. Great. What is a thing? A material object. We're back to matter. Some entity or object, anything. Okay, so again, a thing is an object, and an object is a thing. Now we understand perfectly well. Yeah, they don't have any valid definition, so they can't say that a black hole is an object until they define the word object in a rational manner that can be used consistently. Here we cannot use it consistently because all we have is a circular definitions, just a bunch of synonyms. That's all we have. We don't know what a thing is yet. Mass, there you saw it, substance is mass. Okay, so what is mass? They have 7 definitions of mass at the Wikipedia. We don't know which one they're referring to. What is a volume? Well, a measure of regions. What is a region? A concept. Right? There's no such physical object, standalone object called a volume. So by having volume, we don't know what they mean. You know, what are you saying? Volume is a dynamic concept to make matters worse, because volume means that the rubber ducky is pushing the water outwards from, where it's entering. So when you put the rubber ducky inside your bathtub, the water it displaces, that's what we call volume. So it's a dynamic measure of something. Okay, and a three-dimensional space. What is space? Well, it's a mathematical space. Okay, 3D space is mathematical space. I hope you understood now. In which 3 values, coordinates, what is a coordinate? A value. What is a value? Coordinate. Are required to determine the position of a point. What is space? Well, again, a 3D continuum. What is that? An expanse. What is an expanse? An increase in distance. That exists, always exists. Everything exists beyond Earth's atmosphere. Yeah, until they define these words in a rational manner that we can use them consistently, all these people are just chasing their tails around. We have no idea what they're saying because they're just talking gibberish. That's it. And so, yeah, and people say, well, Bill, you're hopping too much on definitions, on language. You're doing word salad. You're doing semantics, rhetoric. No, this is known as the foundations of physics. Foundations of physics. You need to define the words that you're going to be using to give a physical interpretations. These people have never done that in the last 3,000 years, at least 4,000 years. So we don't have objects. We have concepts, and they're moving concepts around. And they're mathematical concepts, and they think they explain something by saying, oh, the field broke down your door. Now, the field cannot break down my door because there is no physical object called field. It's a bunch of numbers. You can't use field as a physical object. And to say that particle is the vibration of the field, you're vibrating the numbers. What the hell are you talking about? Again, it's all gibberish coming out of mathematics. Okay, so because of this, we have these black holes that we don't know what they are. They say it's an object, it's not an object. Whatever it is, it's a nothing because it's all mass and no substance. We cannot explain with that how it moves a star that's gazillions of miles away from it. So we cannot understand the mechanism. We don't know what exists out there still. So we haven't answered any question of how the universe works by saying black hole. But it gets worse because a couple papers came out now in the news where they insinuate that they have a new theory. And the theory is that dark matter is made of black holes. Now, how's that? Okay, I hope you like that. Here it is. New theory of black holes solves problems of dark matter. Great, we finally solved the dark matter problem. And this references a paper, so this is just the public version, but this references a published paper, by the way. Okay. Over the last century, 3 questions have confounded the field of theoretical physics. What is the nature of the black hole singularity? What happens at the end of the evaporation process of black hole? And what is dark matter? There is a remaining mystery in each question today. Okay. However, it turns out that all 3 questions can be connected by a simple hypothesis. Dark matter consists of remnants of very special kind of black hole, a black hole without a singularity. Okay, so we have a nude, there used to be a naked black hole, which was a singularity without a event horizon. This is the opposite. It's the event horizon without a singularity, okay, which formed in the very early universe. These non-singular black holes evaporate, like Stephen Hawking, you have to mention, some authority there, thought, but then do something surprising. They stop heating up, instead cooling off to form remnants. Due to their special properties, these old and cold remnants may constitute all the dark matter in the observable universe today. Okay, so now you know it. Now you're smarter than the smartest out there. Dark matter made of black holes. We don't know what dark matter is. We don't know what a black hole is, but dark matter is made of it. Okay, so I hope you understood. Okay, so here you have a second paper. Again, I'm not going to read all of it. Primordial black hole as dark matter candidate. Again, they have all these papers that are out there, and it's a new fad, right? I guess it's like string theory. It started out badly. Nobody believed in string theory. Today, everybody believes in string theory because they have no other option. They have no other alternatives. And this is more or less the same thing. What these people are saying is, hey, dark matter could be made of black holes. Hey, I like that idea. Instead of WIMPs, massive particles, whatever nonsense there. Instead of WIMPs, they're made of black holes. Now, that's easier to understand because black hole already weighs a lot, right? A lot of kilograms there. No body, no matter, no nothing, no atoms, right? But a lot of mass, a lot of kilograms, which mathematicians can work with, and the dark matter is made out of all these black holes, and now we can understand everything in the universe. Okay, so let's find out. Here you have the galaxy, normal galaxy, okay, and it's going around and round and round, right? And what these people have done is they say, hey, we're going to replace the black hole, the dark matter that's on the outside, that forces the stars on the outside to travel faster or just as fast as the ones on the inside. And what we're going to do, we're going to sprinkle black holes on the outside. And here it is. There it is. All the black holes around the toilet. Okay? And so, yeah, we have a problem here because, first of all, the shit there, the caca, the brown stuff, they can't see that, so that's invisible. And then the black holes are also invisible. So, they can get away with murder. They say, hey, we have all this dark matter, and it's got all these black holes, and we can't see any of it. So what you're really staring at is this. This is what you're staring at. You're staring at nothing. And they say, hey, what we think is happening in there is that, that center part is the dark matter, and it's made of black holes. And we can't see the dark matter, we can't see the black holes. Someday they might take pictures of this, I don't know. But this is what they have. They have a toilet without anything in it. That's what dark matter is. Now you know. I would call it white matter because, without the black hole, without the dark matter, I would think it's white, light, some shiny thing out there. I don't know. You tell me. But there's a corollary to all this, and this is what you got to take home with you. And I'll be answering questions at the end, so you can hold your questions until then. But this is what you need to take home with you, okay? Keep this in mind. What is dark energy? Now, how do you like that for a question? I've got the solution. Okay? Energy is another form of mass. Remember, E equals mc squared. E is energy, m is mass times velocity of light squared, right? So energy is another form of mass, and they're talking about dark energy. So it's dark mass, dark kilograms. Got it? But it turns out that these kilograms, these masses, like dark matter, it's made out of black holes. So now we can replace one on top of the other and say, hey, dark energy is made of black holes. Okay, you see? I came up with that, so I want my Nobel. Okay, please send it in my name. So here it is. Okay, this is the corollary. We have the dark energy, right? Which is, 73% of the universe. And dark matter is only 23. If dark matter is made out of black holes, why not dark energy as well? That's the next step. That's for the next generation of people to come up with it. So I suggested it first, okay? I just want to make sure I log that down. I want my Nobel, okay? And yeah, a black hole is all mass, no substance. Right. Dark matter is a bunch of black holes. So it's a bunch of all no substance, all mass, no substance, right? What is energy? Well, it's another form of mass, and that makes dark energy made of dark mass. In other words, black holes. Now, how do you like that for reasoning? Hey, that's rational reasoning for you, and we'll call that a day. Okay, so I'll open the floor up for questions now. Anyone who wants to ask a question, give me 10 seconds until I receive it, and then you get the answer back in maybe around 10 seconds. Okay, so there it goes. Let me know what you want to ask. You can ask any question. No personal questions. My age, please. I'm too old. Okay? Give you a second here. Rope atoms. No, there's no such thing as black holes. We have a totally different explanation for black holes, and I've explained that in the past. I won't go over that today, but because, again, a picture's worth 1,000 words, and a movie is worth 1,000,000 words. And I have a movie showing, a video showing how to produce the black hole phenomenon without using mass. It's got nothing to do with mass at all. Okay, so this notion that they do everything with mass out there, gravity and mass, no. In the case of dark matter, at least, it's very simple. You have to answer a single question, which they've never answered. And once they answer that question, they've got it made. And that is, why don't stars fly away on the outside? Why do they keep rolling around the center of the Milky Way, for example, or Andromeda, or whichever galaxy? There's Andromeda back there. I don't care, just tell me why the stars on the outside, like in that picture there, right? Why don't they just fly away? What physical object retains them in the galaxy? Why doesn't the galaxy just split apart and all the stars just go flying out into space? What's holding them there? That's the question you got to answer. Okay? And until you can answer that question, don't bring your mass nonsense into the discussion. Mass is not going to solve or not going to give us an answer. We need to figure out what physical object, invisible, intangible object is out there, okay, that prevents stars from leaving the galaxy. That's the only question you got to answer. Once you answer that question, you're done. You don't need mass. You don't need anything. Okay, I don't see any questions, so I guess I'll call it a day. If you have questions, put them up for in the